All right, let's go ahead and get started. Any questions before we do? All right, so last time at the end of the last class, we talked about this binomial series, which is a Maclaurin series. So you can build them up in the exact same way. But if you have things that look like this, where you have, f of x equals 1 plus, and I think we modified this to say ax to the k, that these things give us the opportunity to use a little bit of a shortcut. One thing we haven't talked about yet is where these things converge, so what their radius of convergence is. And for these is actually kind of complicated, but in general, the biggest thing we can say for sure is that, so this second term is binomial, this ax, if the absolute value of that is less than 1, we have convergence. So this is a general rule that you can follow. So I know it was several days ago, but how would we apply that to this series that we built? What is our value of a? Negative 1/4. So we have this, the absolute value of negative 1/4 x is less than 1, which gives us absolute value of x is less than what? So basically that's our radius. As long as x is between -4 and 4, we get convergence. There are other values outside of that where we have convergence, but this is what we can say for sure. We have absolute convergence inside that radius, inside that interval. That was the last little thing I wanted to say about these kinds of series. How we do? But
how did we find that a equals negative 1/4?
yeah, that's a good point. It's a good question. So we did this a while ago.
Yeah.
So and this kind of bottom line, this binomial series are things that look like this, basically 1 plus some second term raised to the power of k. What is our coefficient of x, basically? So when we first did this rewrite, or the 1 over radical 4 minus x, it seems like the coefficient is -1, right? But then we had to factor out this 4. Why did we have to factor that 4 out?
We need to follow geometric series formula.
It's not a geometric series, but you do need that 1 in that first term there.
Yeah.
Kind of like you do with a geometric series, but that's more coincidental than anything. This is not a geometric series. So you need that 1 there. So after we factored out that 4, then we got this coefficient of x to be -1/4. So that's where that a comes from, is what the coefficient of x is when we get it into a form where we can do this binomial expansion. What else? Okay. Can we do a Maclaurin series for this thing here? So in general, how do we develop a Maclaurin series? Or what is a Taylor series? What is a Maclaurin series? We've forgotten? Not bold today? What's a Maclaurin series? Centered at 0. Okay, that's part of it. So we're gonna have this piece of data. We know that a equals 0. So beyond that, how do I build this thing? What's that? Okay, I have to find some derivatives. So if this is my function, how would I find my first derivative? So 1 over this thing, right? Times, is that it? Okay. You all right with that? Would you rather see a better way to do it? Okay. With natural logs, there are certain things we can do to rewrite. We remember what they are. Yeah, we could write it as log base e, but I mean, there are certain things we can do to kind of. Yeah, I think you're both saying the same thing. So these are equivalent, right? We take a derivative of that in a easier way. One over 1 plus x. 1 over 1 plus x. Was that minus or plus for the next one? Minus 1 over 1 minus x. Good. Okay, so plus, right? All right, we got the first derivative. Now we can do what can we do now?
Starting to be certain down.
Okay. Right. So let's find. I think we can find C naught and C1, right? What is C naught? So it comes from f of 0, which comes out to be 0. C1 comes from f prime of 0, which is 2. Probably can't see a pattern yet on these coefficients, so what should we keep doing? Finding more derivatives. What's the second derivative? Maybe I'll rewrite this. 1 plus x to the negative 1 plus 1 minus x to the negative 1. Does that make it easier to take a derivative? What is it?
-1 to 1 plus x.
Okay. Minus 1 minus x to the negative 2. Can we get another one?
2.
What does the sign end up being on this thing? 2 times 1 minus x to the negative 3. Is it positive or does it just go back to negative? So, yeah, 1 minus x to the negative 2, the derivative is negative 2 times 1 minus x to the negative 3. And then you multiply it by another negative 1, right? So I think because of that, this second term will always, like, I think the first one alternates, right? Negative 6 times 1 plus x to the negative 4. Minus 6 times 1 minus x to the negative 4. All right, so can we get some more coefficients? What is C2? Negative 1 minus 1. So f double prime of 0 over 2 factorial. So is that -1? All right, I'll go up to C4 and then we can talk. So C4 I think comes out to -1/2. -12 over 24. The last one? Yeah, sorry. How do I get what?
Negative.
C2, so plugging in 0 there. Basically, if the inside of all the parentheses are gonna come out to be 1, right? Okay, so -1 minus -1 minus 1, right? -2 over 2 factorial.
Oh, right.
Um, okay, so what do we notice here?
What about like that? This- oh,
Okay, I think the patterns are kind of hard to see. Is there something else we could have done here?
it's like the-
Yeah, so the denominator. Yeah, these denominators are always going to be whatever n factorial is. What else? What if we go back to this form here where we had 1 over 1 plus x plus 1 over 1 minus x? Can we make power series out of those? So this is something we've done before. I think we've done these exact ones a few times. 1 over 1 plus x. If we represent this as a power series, I think we can do this without the Taylor process, right? How does that come out? Close. 1 minus x plus x squared. Minus x cubed and so on. How about 1 over 1 minus x? That's the one that's purely not alternating, right? If I add those together, what do I get? So 1 over 1 plus x. Right. And then what are all the other ones? What are all the even powers going to do?
So,
They're going to double. So 2 plus x squared plus 2x squared plus 2x fourth and so on, right? Is that something we can generalize? X to the 2n, which is essentially, is that all? Yeah, so we need 2 times x to the 2. So I mean, even though we have these Taylor series tools, these geometric series tools. Be ready to look for which one of those is actually better for the job. I think this one, the geometric series tools pop up, especially after you take that derivative. Are we done? Why not? I don't think we can. Yes, but I don't even think this is the series I want. Why is this not the series I want? This power series is for this, right? But that's not what f of x is. We have to integrate. So we took a derivative to get to this place where we could take that, or we could do that power series representation. Now we have to integrate to go back. So let's do that. What is the integral of this thing? So this is probably the first integration technique you used, was the basically undoing the power rule. N is a constant. Yeah, so we're integrating with respect to x.
So 2/2.
So yeah, basically, so increase the exponent by 1, divide by that new exponent, and then carry the constant of 2. So I believe this is the series we care about. But where does it converge? How could we find out where it converges? Ratio test would do it. Is there a faster way to get it? So in general, I'll tell you the ratio test will pretty much always tell you where it converges. I'm going to push back on it because I think there's a more efficient way, a more quick way to get that radius. How did we build this series? What was it? Right. So the derivative series, and how do we build this derivative series? Okay, how do we build those? You just rattle off these terms for the most part, right? What enabled you to do that? They're geometric series. So we know a lot about where geometric series converge, right? Where do they converge? They converge where the common ratio, the absolute value of the common ratio is less than 1. So for us, that'll be absolute value of x is less than 1. So we combine 2 different geometric series, both of them have the same radius. Which one? So we combined 2 geometric series, right? What's the common ratio of this series? Negative x. And this one? Yeah. Basically, the radius is going to be whatever the most restrictive one says. So this one's going to be absolute value of negative x is less than 1. This is going to be absolute value of positive x is less than 1. Those are both going to lead you to absolute value of x being less than 1. Questions? Right. Show you one more tool, one more thing we can do with Taylor series here. I want to find that limit. So we haven't talked about limits, I think, in this context, but I believe strongly you could have found this limit before learning about Taylor series. How would you find that limit? L'Hopital's rule work. Is that legal here? Got it? Yeah, I think it does. But let me show you one more thing. So we know that e to the x is equal to a Taylor series, right? Do you remember what that was, or should we build it up again? Here's what I want to do. I want to turn e to the x into a Taylor series.
It's like 1/.
Let's rebuild it again. So I think it comes out to f of 0 is 1. All the derivatives are e to the x, right? So 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. So it comes out to be x to the n over n factorial, right? So I can do this here. I want to evaluate this limit by swapping in my Taylor series, or the Taylor series for x. So 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on, minus 1 minus x all over x squared. So basically, I took the exponential function and replaced it with its own Taylor series, which we know we can do. One thing we talked about when we built up that e to the x is that that Taylor series converges everywhere. It's a perfect representation of e to the x. So what else can I do now to keep looking at this limit? Yeah, so these cancel these. So I have the limit as x approaches infinity of what? 1/2 plus x over 6 plus x squared over 24. Basically, all these powers of x got reduced by 2. So the x squared over 2, divide that by x squared, I just get 1 over 2. X cubed over 6 divided by x squared, that becomes x to the first over 6. What's that limit going to do? It goes to infinity. With L'Hopital's rule, told you the same thing. Okay, so again, just another avenue to handle these things. How are we doing? It might. There might be, especially when you start dealing with things like factorial. Then, yeah, there are certain functions that just cannot be differentiated. So keep an eye out for those. What else? All right, that's all I got for you for chapter 8. So chapter 9. So I guess I should give you a little bit of a heads up where we're going. Next test. So the last one before the final takes place on, is it the 17th? Yeah, week from Wednesday. Basically it'll cover from 8.4, which was like, yeah, from 8.4 up to 9.2. So we're starting 9.1 now, but I'll post all the review stuff when I get a moment. I'll post it today. That should be easy for me to get a hold of. But yeah, that's where we're marching to. And again, I'd like to have Monday be a review day as much of it as I can. Next Monday. Question?
It'll be the same format as last time.
Exact. 10 multiple choice, 2 free response. They just sent it out yesterday. So yeah, same number and types of questions. But yeah, we'll talk more about it as we get closer. So why don't we talk about something called parametric equations. Polar coordinates we'll touch on after the test happens, but yeah, the next 2 sections are specifically going to talk about parametrics. So let me show you a weird curve here. Is this a function? I see a lot of vigorous no's. Why is it not a function? Vertical line test. Why does the vertical line test tell you whether something is a function or not? So, and that's why the vertical line test works, is because a function is a thing that takes in one input and gives exactly one out. I could draw a vertical line many places on here if it's actually vertical. There you go. So for that single x value, I have lots of y values, right? So we say y is not a function of x. But if we look at this a slightly different way, what if instead of asking if y is a function of x, what if I bring in this parameter t? So basically what I'm going to do with t is, for every value of t, I'll have, you know, some map that maps t to x and something else that maps t to y. So basically what that's going to allow me to do is, for every value of t, I get a unique xy point here. And the arrowheads are showing that basically as t increases, this curve is sweeping this way, as opposed to the opposite way. So if I think about it that way, can I say that these points x, y are a function of t? Which I grant you is probably a way you've never thought about functions, but does it still fit that, you know, that bottom line definition of what a function is? For a single input, I get a single output. Okay, so that's basically what we're going to be talking about now, is these curves that if you graph them very much fail the vertical line test, but when we ask if they're a function in some other way, they really are. So even this weird thing here. So let's start off by drawing one of these things. So basically my independent variable is t. And what do I get from a single value of t? I get a point in two-dimensional space. So I want to sketch this curve. Think back to, I don't know how many years ago, but when you were first learning how to graph things, what was like the very first, most low-tech approach you had to take to graph something? That's where we're going to start. We're going to go back to baby steps. So we're going to pick some t values to try, and we're going to get some x values and y values. What's the standard like list of x values you would always try when you graph something? 0, 1, 2? I'm going to go and go into the negatives a bit. But let's get some of these values. So when I have these t values, what x, y values do I get? I'm going to start easy. Double check. Screw up about 1 in every 10 simple calculations, and I made some ones. We agree? Okay. So what does this thing look like? No idea yet. So I'll start with t equals -2. That gives me the point 8, -1. So I'll be a little bit rough about this. So first point, and then next. Okay, so the thing we have built. I'm just gonna graph the points that we have made. It looks like this, right? Tracing out in this direction. So the thing that we made, is it a function? Or is that function even, is that question even fair for me to ask you without more detail? So is y a function of x here? No. But I think that the points x, y are a function of t. What is this thing? What do you think it would be if I would have drawn it more neatly? It is a pretty common curve. It absolutely is parabola. Just open the right.
Theoretically, like, not this specific function, but could look like a parabola and then twist somewhere else.
Yeah, so I mean, this one is like, no, you think of parabola as opening up or opening down mostly, right? That's when it's a y equals something x squared parabola. This is x equals something in terms of y squared. But yeah, they're all also parabolas that we can rotate them through any angle. They're not just.
So these all quadratic functions I got essentially shifted 90 degrees.
This one is. But yeah, we can do more varied things with them. Questions here? What about this one? So with the last one, I didn't give you an interval for t. This one I am. What are some good t values to try? Zero, pi, and 2 pi are good. Let's see if that's good enough. When t is 0, what are x and y? And 0. How about pi? -1, 0, and 2 pi. I don't think that's enough. Yeah, let's do the halves. So I know that basically it looks like I have something that starts at 1, 0, passes through -1, 0, and then returns to 1, 0. What happens when t is pi over 2? 0, 1, 0, -1. What am I about to graph? Circle. It's a very, you know what? Let's just lean into how bad this is going to be. And I'm going to show which way we graphed it. Let's be more specific. What circle is this? You can circle? Yeah, where's it centered? What? The origin. Centered at the origin. What's the radius? So let's kind of unite this to things that you've probably already seen. Is there an equation you more associate with this circle? So x squared plus y squared equals 1 is probably the first circle you ever graphed. How does this fit with the parameters I just used? What if I plug them in? Right, so that's not a coincidence, is that this identity falls out of it. So cosine squared of t plus sine squared of t equals 1. That basically just says 1 equals 1. So in parametrics here, we get the unit circle. And one more thing I want to point out, so I'll write down, which way did we trace it out? counterclockwise, or if you prefer anti-clockwise. Questions here? What does this thing look like? Let's try to avoid like plotting out points, but let's talk about the differences here. We still have x is a cosine, y is a sine function. What other changes did I make? Which coefficient?
Two cosine.
Okay. So I have this coefficient of 2, and I have this coefficient of 3. Let's talk about them one at a time. This made a circle of radius 1. At the center, at the origin. What is that 2? So we got to vote for that, changing the radius to 2. Why? Right, so it basically, if I'm looking in the y direction, it's going to basically stretch your circle out from, instead of being from -1 to 1, it's going to go from -2 to 2. In terms of trig, do you remember what they call that value? Basically, that vertical stretching as the amplitude. So basically, that 2 is the amplitude. So now we have a circle of radius 2. What does the 3 do? Change the what?
The sides. So if your t is pi, so cosine pi equals.
Okay. What's that going to do to the graph of the circle? Like the what? I don't know. Let's see. So this one, I said that t had to go between 0 and 2 pi. How many circles, so how many times did it trace out the circle if I do it like that? Is it exactly 1? Okay. So that's just with cosine and sine of pi. This one, if I let t go from 0 to 2 pi, how many times will this circle trace out? Exactly 3 times, right? So does the term period or frequency resonate, either from physics or from math itself? Basically, that 3 there, you can look at it both ways. It either triples the frequency or it cuts down to 1/3 what the period is. So the period of a trig function is essentially what the change in input needs to be to get a full cycle of the behavior. So in this case, let's say I want to have my t interval go from 0 to whatever it needs to be to only trace one circle for me. What should that number be? Exactly 1/3 of what it was last time. So doing that, I'm still going to get, basically I could just copy and paste the drawing. Radius is 2. But what direction am I drawing this? The last one was counterclockwise. Do we think this one's counterclockwise, or did it change direction? Let's think about this. If t equals 0, what point does that give me? 2, 0 this time, but basically the right hand, basically the maximum, the furthest point right. What about when t is equal to pi over 6? Where does that put me? should be 0 too. So I still believe we're counterclockwise, we're just moving at a faster rate. So circle of radius 2, center didn't move, and still counterclockwise or anti-clockwise. How we doing? Questions? Okay. What the heck is this? So I want to find a Cartesian equation. And what I mean by Cartesian equation is that I'll write it in a phrase here that you're going to see a lot. Eliminating the parameter. So the parameter is, in this case, t. Basically, it's this third variable, like this intermediate variable that unites x and y. But my goal here is I would like to get to a place where I can write an equation for x and y that only involve each other. That does not involve the parameter t. But it might be helpful if we first knew what this looked like. Do we have an idea what this looks like? Should it be circular? Maybe not a full circle, but should it be? How do you know it's a semicircle? Right, so I don't have a full 2 pi for like the length of that t interval. I just have pi, so that leads me to believe it should be a half circle. But where's that circle going to be? How did you get that?
Adding 6 and 7.
Okay. So one thing I want to point out here is let's just talk about what all the different numbers do. You're saying because of the 6 and 7 that I have, let's compare this to something else. If I had x equals 5 cosine t and y equals 5 sine t, based on what you just told me, that should give me a circle of what radius? 5. We still think that circle will have a radius of 5. So that's what the 5 is doing. The 5 is altering the amplitude. And since both of the sine and cosine have a 5 multiplied by them, I think it's still going to be circular. It's not going to be stretched out in one direction versus the other. But what are the 6 and 7 doing? Let's just stick with the 6. If I have a circle of radius 5, and I add 6 to, if I add 6 to x, what's it going to do to that circle? It's going to slide it to the right 6 places. If I add 7 to the y value, what's that going to do? It's going to slide it up 7 places. So basically, we slide every point of the circle, including the center. So now the center is going to be at 6, 7. And we'll have a circle of radius 5, so roughly like, not even close. Let's live with it. So I don't think it should touch either axis. But also, I don't know if it should be that full circle, right? What part of that circle should it be?
The left side.
How do you know it's the left side? So pi over 2 is the vertical, and why is it the left-hand side? Why do I keep the left-hand side, not the right-hand side? Why is it still going counterclockwise? Okay, so I will tell you, yes, it's going counterclockwise. But since we haven't talked about the opposite, do we understand what change I could make to these equations that would make it graph clockwise instead? Negative where?
-5 or
It's negative. So basically. As I start from the right-hand side of the circle, what's the way you're used to seeing it traced is this way, right? What's X doing? Decreasing or increasing? Decreasing. And what's Y doing? So basically, you just have to disrupt that. Which means you just have to basically change one of them. For example, if I go this way, what's happening to X? And Y? So is you need to change one of them. So we still have counterclockwise. And I believe you convinced me that it's only the left-hand side, right? And it graphs like this. We good with that? Go ahead.
functions for the. Clockwise or
That's a good question. So the question was, is it these functions or the interval itself that tells you counterclockwise? Let's break it down. Does the interval have anything to do with it? I don't think it does. I think if the interval was from 0 to pi over 2, or negative pi over 2 to pi over 2, or really anything, it would still be like it. So then does it all just fall on the function then, the way the function is defined? Okay. So yeah, it's the way the functions are defined that gives you the orientation. All right, so we wanted to find a Cartesian equation for this. Any thoughts about how to do that? I'll give you one option that I promise you won't like. We could solve for, let's say X. We could take this X function as X is a function of T, solve for T, and then plug whatever that is back into this other T. Unless you don't take like the inverse sine of cosine of, no. So let's do this instead. Do we remember back from our youth how to find the equation of a circle in Cartesian form? So let's kind of build it back up again. You told me several slides ago that this unit circle was x squared plus y squared equals 1, right? So let's generalize that a little bit. It's x squared plus y squared equals whatever the radius is squared. But that's a circle that lives where? Or that's centered where? You remember how to like transform functions? If I want to slide them over left and right, up and down. Exactly. So x minus, I'm going to say h. If I do x minus h squared like that, it's going to move it to the right h units. Similarly, if I do y minus k squared, it's going to slide it up k units. So this is a more general thing. This is a circle whose center is at hk and whose radius is equal to, radius r. So if we specify it for our circle, what should all these constants be? X minus 6 squared plus y minus 7 squared equals 25. One more thing to be careful about. That equation right there will give me a full circle. Divided by 2 will just make it'll shrink it. It's 11 o'clock. That's probably more than I want to get into in 30 seconds. So let's talk about that next time. But one thing I want to make sure of is, are we good on where this equation came from? Okay. All right, we'll go ahead and stop there. We'll pick it back up on Wednesday.